Okay, let's start with chapter 8, Exponential and Logarithmic Function and Calculus. We already made a chapter 7 in the third portion. Now we will apply it to calculus here. In the page 528, there is the proof using the limit method to represent what is the derivative of e to the x power. Well, here it is the theorem that we will use for this one. Instead to use limits, yes, this is the derivative of e to the x power. That is very easy to remember because it's e to the x power. It's the same in this situation. But what happens when we have a situation like this? E to the u power. What is the derivative of this with respect of x? Is the exponent is u, I mean a substitution, is e to the u power times the derivative of u with respect of x. But if you feel better, we may use this notation, e to the u power times u prime, similar to the chain rule. Now, let's make some exercise. Now, if we have this example, that is here, e to the x power, well, this is the basic situation. What is the derivative of this? Will be y prime is equal to e to the x power. That's it in the example. But let's make the example number 4 of your book that says f of x is equal to e to the 1 minus x power. Now in this situation, we don't have an x as exponent. We have this expression 1 minus x that will be our u. This u will be 1 minus x. Now u prime will be negative 1. Derivative of 1 is 0. Derivative of negative x is negative 1. Now, following this property that is on the top, we only have to write the derivative of the function f of x is e to 1 minus x multiplied by u prime, that is negative 1. Then f of x is equal to negative e 1 minus x. And that is the answer. Now, let's solve the exercise number 8 in your book. Here we have that is negative, the exponent is negative 1 over x to the second power. Now this will be our u minus 1 over x second power. Let's rewrite this one. It will be negative x to a negative 2 power. Now the derivative of this expression, because we have to find u prime, will be negative 2 is going to multiply negative times negative 2 x. Negative 2 minus 1 will be negative 3 here. U prime will be 2x to a negative power. U prime is 2 over x to a third power. Now, this expression, we will make that notation in this part. Prime, we copy the same. This is because this is our u. Multiply by what we found in this place, 2 over x to a third power. Now, to rewrite this in a proper way, will be 2 multiplied by 1 over x second power divided by x to the third power. That will be the answer. Now, in this example number 12, because we are making derivatives, here we have a multiplication, we have to use first the product rule. Remember, the product rule was, imagine that we are using f and g multiplying. That means we follow the pattern, will be the original f times the derivative of g plus derivative of f times original g. But remember, this is because it's a multiplication and addition, doesn't matter the order, we will have the same result. Now, in this situation, f is equal to x to the second power. and g is equal to e to the negative x power. Now, derivative of f in this one will be 2x. Now, the derivative in this situation, e to the x power, remember, we have to make our u. U will be negative x, u prime will be negative 1. Now, making the operation, here will be negative 1 because it's the u prime multiplied by e to the u. And that it is g prime is equal to negative e to the negative x power. Now, following the steps of the product rule, we will have original f, that is x second power, that is y prime, x second power. Now, that is original f. Now, g prime, that is what we found here, times e to the negative x power, plus f prime, that is 2x, multiplied by original g, that is e to the negative x power. Now, here we have the expression, this is the derivative, but let's make it because we have common factors. Y prime in the situation, the common factor is dx, x outside. Now, another common factor is e to the negative x power. What is left is x times negative 1. X times negative 1 multiplied by, left here is only 2. Now, the proper way of this one will be x, the simplest form will be 2 minus x. And that will be the answer for the exercise. The next exercise is this, it's a division, it's a fraction, notice this. We have to use the quotient rule in this situation. Remember, it's f over g. Now, the quotient rule is the original g times f prime minus original f times g prime divided by g to the second power. Now, in this situation, we have to identify what is f, that is e to the x over 2, and what is g, that is square root of x, that is equal to x to the 1/2 power. Now, f prime, we have to use the rule that we says that this part will be u. U is equal to x over 2. Now, u prime will be the derivative of x, that is 1. That is definitely we will have 1/2 as result. Now, we multiply u prime times the original x second power. This is f prime. Now, g prime that we have in this part is the derivative of x to the 1/2 power. We send the exponent to multiply, and then we subtract 1/2 minus 1 will be negative 1/2. That is f prime and g prime. Now, let's use the quotient rule to complete the statements. Okay, let's follow this pattern to find f of x prime. The denominator is g to the second power. That means the denominator to the second power. That is a square root of x to the second power. It is x. Now, g, we know that is x to the 1/2 power, or a square root of x. Now, f prime, that is this result, will be 1/2 times e to the x over 2 minus, because it's minus, times f, that is this part, e to the x second power, multiplied by g prime, that is this expression that is here, 1/2 x to the negative 1/2 power. I don't have too much space here. Now, let's try to simplify this. F of x is equal to, the denominator will be x. Now, here is 1/2 x to the 1/2 e to the x second power, x to the over 2, sorry, minus 1/2 x to the negative 1/2 multiplied by e to the x over 2. Now we have like terms in this situation. Remember, we may do a common factor here. We will have 1/2 common factor. What else we have in common is the x, but this is to the 1/2 power and this is to the negative 1/2 power. Remember, we always choose the lowest exponent, that it will be x to the negative 1/2 power. And e to the x second power, x over 2 power, is in common also, e to the x over 2. We open parentheses, and then we have to see what we have. For this one, in this part, the 1/2 is outside, the e to the x over 2 outside here, but the x, remember, when we make common factor, we subtract the exponent. It will be, the exponent that is outside will be 1/2 minus negative 1/2. In other words, will be 1/2 minus negative 1/2, that is 1. The exponent that we get here is x to the 1 power, minus, because it's subtraction here, 1/2 is outside already, x to 1/2 power is outside, and x to over 2 outside is outside here. That means we have minus 1 over what? Over x. Even here, we may simplify this, so making the division of this one, because it's the same variable. Let's do it. Will be 1/2 negative 1/2 minus 1. That will be negative 3 over 2. X to the negative 3 over 2 e to the x second power minus x minus 1. Now this is negative. Sorry, I didn't write it here. This is negative. Now let's write it in this way. E to the x over 2 multiplied by x minus 1 divided by this 2 that is in the denominator, x to the 3 over 2 power. And that is the answer for the exercise 14. I have to solve this in less than 1 minute because the time on YouTube allowed me. Now the derivative of this, we have to make the chain rule here. I will send the exponent to multiply. I copy this, minus e to the negative x power. And then I have to multiply by the u prime, the derivative that is inside. I make a chain rule here. Now, what is the derivative of the thing that is inside the parentheses? The derivative of 1 is 0, minus the derivative of this part. What is the derivative of negative x? Is negative 1, multiplied by this part, that is e to the negative x power. Now, y prime will be 2 minus 1 to the negative x. Negative and negative will be positive, e to the negative x power. If that is the answer, you have to solve the exercise 3, 5, 7, 9, 11, 13, 15 of your book in page 532. The odds in the same page, that is from 3 to 15.